Hi, my name's Dan. This video is one of quite a large set of videos in which I create a simulated 4-bit CPU computer core using simulation software which is called DigitalWorks, which is what I've got up on the screen right now. This software is free and there's a link to it in the description down below. Also in the description down below there will be a roadmap of where we're going in this longer set of videos. We're kind of hovering somewhere around halfway through, and the larger set is split into smaller sets of dealing with specific topics and specific components for this 4-bit CPU, which is, I can't remember if I just said, is being done from the principles of basic logic gates. So I do encourage you to play along with me and go through the whole set and create this CPU, because it's a lot of fun if you're that way inclined. Anyway, this smaller set within the larger set is about creating a memory bank component which can be used in the CPU. And in the previous video to this one, we discussed what we're going to need to put together for the memory bank. And at that point, we decided that we need a specific component, which is a two-bus register, which is a register which can communicate with two separate buses at any point in time. If any of this that I'm saying seems to be in an alien language to you, then I'm not going to apologise for that, because digital electronics is a pyramid of knowledge building on previous things. If you don't understand the context of this and you want to know the context, go watch the other videos or other people's videos. There's loads of videos about this stuff out there. So let's crack on. What we're going to do, and actually previously in one of these videos we created a 1-bit register, and what we're going to do in this video is adapt that and then turn that into a 4-bit dual bus register. So I'm going to open the previous one, which is Reg 1-bit, and I'll quickly talk about what's going on here. But before I do that, for safety's sake, I'm going to do a save as and save this as register 1-bit. 2-bus. I'd love to think that as a general rule this is called a double-decker bus, but I'm not sure that's true. So this is the standard 1-bit register that we've got. It uses a D flip-flop at its heart, and it's got several controls coming in. We've got a bus input, we've got a data input. We've also got the ability to output to the bus using the output enable here. We've got the ability to see the value that's being held by having a specific value pin coming off there. And we've got controls here so that we can read from the data input or from the bus input, and we can also set and clear the data that's being held here. And actually adapting this is fairly straightforward, to be honest, because all we're going to do is we're going to take away the ability to do the data read, which is a non-bus input, and we're going to turn that into a second bus input. I just happen to know, because I have been through all this process before, I'm not kind of blindly wandering around directionless, that this is reasonable. If we wanted a really versatile register, we might make a dual bus which also has data input, but we're not going to do that. So it's just a matter of turning this turning the data line into a bus line, and we're going to need to add an extra output enable for that. So the first thing we're going to do is we're going to actually change the annotations. We're going to change that to be bus B, and we're not within this going to specify which bus is which when these are going to be used in a memory bank. Then one of them will become the external bus, and one of them will be internal bus for the memory bank. But at this point, we don't care which is which. We can decide that later. And so we've got to turn data read into bus B read and bus read into bus A read. All I've done is change annotations so far. There's very little extra that's going to be done here. The set and clear are as they should be. The value should be as it is. But the only extra thing we want actually is the output enable, so that we're able to not only read from bus B, but actually give values for bus B as well. So this is going to need an extra one of these things, which is the tri-state buffer. Let's change that annotation so it's output enable A. And we're going to do a second one, so let's just copy and paste that to be output enable B. And wire this up so that we want this to come again from the same queue output. Kind of skirt around a few things here. And this needs to go to our bus B, which is this one here. And then the final part of that is sticking an extra tag on. There we go, and we're just going to move that annotation over so there's that. So actually the adaptation in terms of the 1-bit cell has been pretty straightforward. But we do need to make changes to the template. So we already have set up bus read, output enable, and we've got data, read, set, and clear. And the data is the one that's going to become the bus B. And in fact, what we're going to do is we're going to put bus A on one side and bus B on the other side. And so the read becomes the bus read. And set and clear, we're going to keep at the top. We need to adapt that. We'll just move those over a bit. Edit these annotations. This is bus A. Bus A read. Output enable A. They're already wired up for us, which is brilliant. I wanted to select that pin and move it because I'm being neat. Those of you who know me in real life will know that being neat seems to be a strange thing for me to be. And I'm going to need to label these as well. And so I don't know why I bothered with outlining up, because we don't quite have enough space on here to do all this. So I'm going to expand out. I don't care, but it's going to be bigger. In fact, what I'm going to do is, in terms of these annotations, is I'm going to, I was hoping not to select the pins there. I'm trying to just select the annotations, not the pins. Move them slightly sideways to make it a bit clearer. And copy and paste that set, because then I'm just going to rename them and realign them. So that was bus B. And bus B read. And output enable B. And I've been careful to make sure that I move the right pins into the right places. Let's move that description a bit, and I'm going to just add the fact that it's dual bus. to this description. There we go, 1-bit register dual bus. So I've only got the one to connect up, which is the output enable B to connect to there. Okay. I am confident enough in this that I'm not going to test this component individually. That is the thing that I would normally do with every component, but I want to keep cracking on because we've got more wiring to do because we can't just easily replace in the quite so easily in the 4-bit version. So I'm going to create a 4-bit dual bus register, which is the thing that we're actually wanting eventually. So let's save this. Just checking that it's got the right name up there. 1-bit 2 bus before I save. Save, and then I'm now going to go new circuit. So we're going to do this and start from scratch. So we're going to have a 4-bit. Let's just quickly remind ourselves what was inside the normal 4-bit register. So we're just going to drag one of those in and have a look. We had a bus. We had various controls going into each one. We had 4 of them in a line. And basically we're going to want the same or similar, but we're going to have 2 buses. So let's close that and get rid of it. That was just a way of reminding ourselves what we want. So we want 4-bit register 2 bus, and we want 4 of those. So I'm just going to do Control C and Control V to get 2, and then do the same again. So I'll do it twice. Okay, and I'm going to create a bus line, and fairly commonly for me for a bus line, I also put an LED at the far end. It's not going to hurt, or we might not see it unless we need to get in for any kind of debugging purposes. But whilst you're running a simulation, you can always dive down into the macros that are being used and see the state of things inside the macros. So it could be a useful thing to do. I'm going to copy that and paste 3 times so that we've got a 4-line bus, and that's going to be my A bus. And I'm going to copy and paste the whole thing to make another bus on the other side. That's going to be my B bus. Let's label these bus A and bus B. And I'm going to want, what else am I going to want? Some more controls. So I want a bus read for bus A, an output enable for bus A, a bus read for bus B, and an output enable for bus B. So I'm going to call this bus read. I could give this a bit more space. Actually, I'm going to be lazy. Laziness is the mother of invention. And I'm going to copy and paste those. And then I'm going to reuse this annotation. So for bus B, that's those. And for bus A, that's those. And then I haven't wired everything up yet because I'm going to do a fast forward for that. But I'm also going to want value pins and to wire those up. I'm going to want a general set and clear, which works for all of them. So let's put these. Let's put them at the top here. And we're going to create a little bit of space. And I'm just going to move those further over because I know I'm coming from 2 ends. slightly move that further. I'm going to stagger that to make it look right. There we go. And so that's going to be set and clear. I'm just going to use one annotation for both of those. I can make these a bit closer as well. It's going to be useful. Right, so I need to connect up my bus A, my bus B. I need to make sure I remember which one of these is which. So I'm just going to label them as bit 3 at the top. Bit 2. Bit 1. And bit 0. So for the next few minutes, I'm going to do the wiring up for this, and as I promised, I will fast forward and play you some music. This is the bit that you've obviously been looking forward to, is to hearing that fast forward music again. So here we go. Right, I think I'm done. I'm just going to do a quick visual check round that everything seems to be connected as it should be. So the first check I'm going to do is to check that every pin on these 4 registers is connected. So that's just looking visually around in a circle to check that, and they seem fine. And I wouldn't normally draw it with my mouse. I don't necessarily need to do that for the visual thing, but this is to help you see what I'm doing. Okay, and then I'm going to look at the various inputs and see that they're connected. So bus A, what I didn't say is that it's bus A 3 to 0. So I'm going to edit that 3 to 0. Hopefully I've connected that in the right way. So this is bit 3, bit 2, bit 1, bit 0. And similarly bus B 3 to 0. And so that's 3, 2, 1, 0. These are the bits that the connections that can be easy to make mistakes on, to be honest. And we've got set and clear, so set's going to set, 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 set. Clear's going to clear, 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 clear. And then we've got the bus read for B, in there, in there, in there, in there. Output enable for B, in there, in there, in there, in there, and the other side for A, output enable, in there, in there, in there, in there, and bus read for A, in there, in there, in there, in there. And along with my kind of obsessive testing of components, doing visual checks like this are really worth doing. It takes a little bit more time, but you become more and more confident that you have what you're meant to have. So the next part of this, as always, is creating the template and wiring that up. So we obviously have a 1-bit register there, and I'm going to do just change that name to 4-bit. There's some reconfiguring that I'm going to want to do here. So the value, I'm going to want 4 of those. Set and clear, we're still going to want, but I'm going to take these controls. I'm going to come to the top. In fact, let's leave set and clear in the middle, because then we're going to have output enable and read for bus A and bus B. So we're going to have bus A on the left and bus B on the right. So I will repurpose some things at some point. That one's a bit low. It's just in the way now. So I can move some annotations out of the way. I might not need all of them anyway. No, I just want the annotations, not the bins, not the bins. Come on. There's a good set of annotations. Off you go. Right, let's multiply up the value. I want 4 pins. Got plenty of space on the bottom, so they can be fairly widely spaced. That's going to be value 3 to 0. And move it across. And we're going to create a thing. I'm going to put this inside, but I'm going to start by cutting it outside. So BR for bus read and OE for output enable. And then I'm actually going to make them a little bit closer together. And then I'm going to copy that annotation and use it on the other side as well. And I'm going to use bus A. I'm going to put down here to indicate that this side is bus A, and down here to indicate that this side is bus B. And we don't need those annotations, or those. And I'm actually going to get rid of these pins because I'm going to create a vertical set of 4. I'm going to copy that across there. And I'm going to do a last annotation, which is going to be just 3, 0, which is to label these pins here. And for this one, 3 is at the top. And so we turn it that way. And we want it the same way around, even though it's on the other side. We don't want to turn this over because we want 3 to 0 again. And we're going to mimic that. So that's bus A. Bus B, have we got everything we need? Hopefully the values could maybe a bit more centered. And that should be fine. So I need to now, hopefully that's the right number of things. I need to now be careful as I connect these up, connecting the tags to the pins, but I am going to do the fast forward thing again so you get to hear more of that excellent music. So there we go, and I'm going to save this as I register 4-bit to bus. And I'm going to go through the process of testing this next. So let's have a new circuit and drag in our 4-bit to bus register. We're going to need a couple of buses to be able to do that. This time the buses are going to have, no, I'm not going to put those interactive things on. I'm just going to use tags because I need to use the output the output enabled inputs. You'll see what I mean. Do, 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 do. Bear with me. Right. And attached to that, we're going to do these. I'm going to move that whole lot up a bit. And now, last time I did this, I didn't leave a big enough gap here. It's just in anticipation of the cutting and pasting that I'm going to do. So that's one bus line, and I can create 4 by doing that. And we're going to want a second bus. So I'm going to cut and paste that. Cut a little bit by there. And turn that over that side. And then we're going to want some more inputs. We're going to want an enable input for this bus. Okay. And similarly for this side. So if you haven't seen me do this bit before, this is to add the capability of putting values on the bus as if we had other components. And bus connection 3, 2, 1, 0, same over here, 3, 2, 1, 0. I want to display what values are being held. And then nearly there, ready to test. 6 more inputs for these particular capabilities. Right. So I think we're ready to simulate, or I certainly hope so. Let's start running. So the first thing that happens, we kind of get used to this, is that our register has set itself to 1111. So we're going to be able to test the set and clear. So let's do clear, all off, set, all on, set again, no change, clear, all off, clear again. Right, so let's put the value 10 onto bus B. There we go, and we're going to read from bus B using this. Here we go. Stop that being output enabled, and we're going to output enable to bus A. And that gives us 10 on bus A. That's fine. Right, and let's test in the other direction, but let's use 7 this time. Check that the output enable isn't on before I output enable this one. So we've got 7 on the bus. We've got to read from the bus, which gives us 7 in the register. And then we're going to output enable to this bus with checking that that output enable isn't on, otherwise the simulation will turn off and we'll have to start again. So output enable gives us 7 onto the bus. So that's all working as we expect it to. So in the next video, we're going to take all these components and put them together to make our memory bank finally. But that's it from me for now.